Hey Chem 1 students, we've been learning about atomic mass and isotopes, and here's a lab to help us work on those concepts. Okay, but you have to use your imagination a little bit with this. Obviously atoms are really tiny. In real life, we'd be using an instrument called a mass spectrometer to figure out the isotopes and their abundances in a sample. Well, Troy High doesn't have a mass spectrometer, okay? So we have a lab that's an analogy to that process. So you have to imagine then that this represents our element. Okay, it's actually a mix of vegetables. So we call our imaginary element Veggium. Okay? All right, so now we're going to take a sample of our Veggium element. So I'm going to just take a Dixie cup and scoop out an amount of our element Veggium.
How do we know that this is a similar sample to that?
I think we're just hoping that odds are our isotopes are evenly distributed
Yeah.
based on their abundance in the sample, and that we're getting a representative sample.
Yeah, that's what we do when we use a mass spectrometer too, is we
That's
just
right.
take a pure sample, as pure as we can get of an element, and stick it in there,
Yep.
and sample after sample, we
Yep.
just find similar results.
Now, I suppose what we could do is run this experiment 10 different times so we could see if our results were legitimate.
That's a really good idea, Mr. Heller. Maybe we should
Right.
do it 10 times.
Maybe we should do this 10 times. Okay? If you like to count things, then that would be a great idea.
Yeah. Yeah.
Right. We're going to run it once and assume that our data is very representative.
hmm Now, we've been doing this lab many times, for many years, and we find that the results from one group to another are always very close to one another.
Right. So
Just taking one sample is
seems to be
it works.
legitimate.
hmm
Right. So now here's what we're going to do. We're going to have to know the masses of our isotopes, and we need to know the total mass of our sample. Okay? So I think I'll get the sample mass first. Mr. Moore, you think that's
Yep.
okay to do? So we've got a weighing boat on our scale, which is jumping around a lot now.
I see that.
Do I dare hit the 0 button again? Oh, it's
Oh,
0
there it goes.
itself.
Okay.
Amazing. Okay, so here we go. Here's our element sample. There's the mass of our element sample.
Yeah, don't be too hung up by that drifting a little bit of the
Yeah.
balance. Just 41.25, that's probably fine.
Yep, that'll work.
Yep.
Okay, so now what we're going to have to do is separate out the isotopes that make up our element Veggium. Okay, now
Yep.
our particular make-believe element has 3 isotopes.
Oh, what are the isotopes?
Well, we have some beans in here, which we've cleverly called beanium. Okay, so we're going to have to count out the beans. We have corn kernels in here. Take a guess. We have an isotope that is cornium.
Sounds like cornium, yeah.
Cornium. And finally, this is not quite as common. Are you familiar with a black-eyed pea? All right,
I've
so
heard of that.
therefore, yeah. Therefore, we have black-eyed peanium. Okay?
Yep.
So what we're going to do is separate out the 3 isotopes from each other and put them on these pieces of paper. You are going to have to count how many pieces of that vegetable are there.
Mhm.
And that's going to represent the abundance of that particular isotope.
Okay, I'll turn the camera off so both of us can separate these and put them out so they can be counted.
Sounds good.
Okay, Mr. Hevel, I think that we have our 3 isotopes separated
Yep,
so
nice
that they can be
job, Mr.
counted.
Moore. Yep. So now what you're going to have to do is make a count, an accurate count of how many atoms you see for that particular isotope.
Yep.
And again, this will help you determine the abundance.
So these are all the same element, right? They're all Veggium.
It's all the same element, it's all Veggium, but remember there's different isotopes.
Mm-hmm.
In real life, these atoms would have a different number of neutrons in their nucleus.
Mm-hmm. Yep. So they have a different mass.
Yep.
So we're going to need you, students, to count how many peas, black-eyed peas there are, and then we'll put it on the camera on the benium and the corneum. So we recommend that you pause the video. I'll leave it on here for a few seconds, but I would say pause it so that you can try to count how many of each isotope there are in the sample. So here's the black-eyed peas. I'm trying to keep this still. And then I'll move on to the beans.
This is benium.
The benium, of course. Pause it if you need to count. It takes you longer than the amount of time I'm leaving it on. The corneum, it looks like it's fairly abundant, doesn't it, Mr.
It
Hebel?
does.
Okay, so we'll need a count of those, and then we'll need the mass, the average mass of each isotope.
Right, so now we've got one more task. We're gonna have to weigh the mass of our 3 different isotopes. So back to the balance. Look dangerously, hit the 0 button again.
You've got the touch. I couldn't get it to zero out.
Okay. All right, so now here's black-eyed penium. Okay, I'm gonna dump these guys onto the balance.
Got it?
Okay. There's one isotope. Okay, here comes the benium.
Okay.
All right. Finally, here comes the corneum.
All right. So we'll need the approximate mass of each isotope,
Yep.
and we'll be able to determine the relative abundance of the 3 isotopes.
That's right.
And with
Now,
that,
there'll be some directions along with the lab to help you, to help guide you through the process a little bit. Okay, but at this point you have the data you need to do the weighted average of these 3 isotopes to get the atomic mass of Veggium.
an average atomic mass.
That's right. So look for element Vg in the periodic table. Extra
That's
credit for
right.
those of you who find it.
All right. Well done, Mr. Hebel. Good
Thank
lab.
you, Mr. Mayor.